Hello and welcome to our 5th Google Lunar X Prize Team Hangout. This week we will be talking to the Penn State Lunar Lions and the Omega Envoy teams about their pursuit of the Google Lunar X Prize. To win a team, and we don't know which team it's going to be yet, there's so many variables. A team must land safely on the moon, traverse a distance of 500 meters by any means of their choice, and then send high-definition video back to Earth. And what I love about this competition is just how free-form it is. We can have a walking robot boogieing its way across the moon. We can take off, and land somewhere else, or just do the normal rover kind of thing. During the next year, the Google Lunar X Prize Team Hangouts are going to follow not just these two teams, but all 18 of the teams that are still in the running and registered in this competition as they work their way toward launch, landing, roving, flying, whatever they're off to do, and the video that they're sending back. What makes tonight's two teams unique is their student engagement. Omega Envoy is a team that grew out of the Earthrise Foundation, a foundation that was formed by Florida students that is dedicated to getting student projects into space. This is the first student team of its kind. The Penn State Lunar Lions team is the only university-based team in the Google Lunar X Prize competition. So tonight, we're talking not to a bunch of PhDs, not to a bunch of people that worked on the space shuttle program, but literally the next generation of explorers. And when us professors say it's today's college students that are on their way to the moon, it's these students that are pioneering this trip. So I'm going to start over with Alwyn from the Lunar Lions, Alwyn Paul, he's the vehicle design lead, and ask him to tell us a little bit about what the Lunar Lions are planning.
All right, well, like she said, my name's Alwyn Paul and I'm the vehicle design lead. What the Lunar Line team is doing is we're going to complete the Google Lunar X Prize. We're going to do so by purchasing a place on another rocket. We're not going to build the launch vehicle ourselves. So we're going to get onto a rocket. Hopefully there'll be other secondary payloads on there. There will be other secondary payloads. That rocket is going to take us to the moon. One really interesting thing about that is that we're using a payload integrator called Phoenicia, who used to be one of the competitors in the team, but they dropped out of the prize and started a new thing by pretty much being a broker that bridges the gap between the people trying to get a launch vehicle and the launch vehicle itself. So they're helping us get our launch contract. We have it almost signed. We have it almost completed. We're in the process of doing that. So we'll be launching on that vehicle, which I can't announce yet. It will send us into a translunar insertion orbit and set us on a collision course to the moon. And at that point, that's when our own systems will take over. So we're going to be on a collision course to the moon. If we don't do anything, our lander is just going to smash into it and blow up. But that will not happen.
It will not.
Rocket motor. Hopefully. We'll have a solid rocket motor that is attached to the bottom of our spacecraft that slows us down. It brings us to about 2 meters. I forgot how many exactly, but that's an image of it. So it brings us to a manageable speed. Then the solid rocket motor, which is the part that you see coming off in step 4, that part will be detached, and then thrusters that we have on the sides of our craft will bring us down to 2 meters per second. Once we get to that velocity, we're going to land on the moon. We have crushable honeycomb pads on the bottom of the craft that will absorb the shock from the initial landing. We'll land, we'll take video, high-definition video, pictures, send some data back, and then one of the other requirements of the prize, other than landing on the moon, is to move 500 meters laterally. To do that, the thing we're going to do is instead of roving, we're actually going to hop to the side. The reason we're doing that is because no matter what, there's pretty much no atmosphere on the moon, so you can't really use a parachute. The only way you could slow your velocity down so that you don't blow up when you hit the moon is to have a propulsion system, so rocket engines. So we're going to use that same system that we used to bring us slowly down to the moon to actually make us hop 500 meters, and that will be the conclusion of the mission after we send the data back and take another video.
And this is all something that you're working on at Penn State University. Can you tell us a little bit about the composition of your team?
Okay, Liam, you wanted to say some stuff about that?
Yeah, sure. So I started out on this team, and I said, I'm not an aerospace engineer. I'm not even an engineer, but this is some of the coolest stuff I have ever seen. So I want to be a part of it. And they were like, well, what do you bring to the table? I was like, well, I did acting in high school. I really like public speaking. My major is in information sciences and technology. And they were like, well, that's great. Why don't you just hop on board? And here I am talking to people every day. But it's just one of those things where our team composition is very, very diverse. Previously, on previous space missions, you basically said, hey, Papa President, we need like $400 million yesterday. So the thing that's different about these new space initiatives is that we need to not only have the engineering behind it all, that infrastructure in place. So basically, we need MBAs, we need marketing people, social media people, and we need all those engineers. We even have theater students on our team that are helping to build the actual model of our craft for like museum shows and that kind of stuff. So we have every major under the sun, and there's a spot for everyone, which is kind of cool. Like, it's kind of a unifying factor across Penn State. So, and Penn State sees that. They see it as a huge learning opportunity for not just aerospace engineers, but this whole across-the-board learning initiative.
But aerospace engineers like myself also.
I mean, yeah, also aerospace engineers, yes. But for the non-aerospace engineers, it's also an awesome learning opportunity.
Now, Ruben, your team isn't so much centered out of one university, but you came out of foundation. Can you tell us about your mission and the origins of your team?
Yes, first of all, thank you for the introduction, Pamela, and for inviting me to this hangout. And I'd like to start by saying that I admire the Penn State Lunar Lions because they have that spirit in them to take on the challenge and move forward with what they're doing, which is the same that the students are doing here. So we are the pioneers of the emerging lunar market, per se. So I wanted to start out with that. And then to answer your question, the Google Lunar X PRIZE was started by a group of students here at UCF, at the University of Central Florida. I was a sophomore in college, and I was Googling the astronomy picture of the day because I was in an astronomy class and it was a requirement, and I happened to bump into the Google Lunar X PRIZE website, and I said, wow, I could win $20 million. Okay, let's go ahead and do this. I looked at the requirements, and I said, okay, this is a piece of cake. No fear as a student. You got nothing to lose. Let's go for it. Why not? So gathered a group of other students. We looked at the challenge. We figured out how we're going to do this, and we were able to raise the funds to register a team. And from there, we've been making history the same way that all the other teams have been as part of the Google Lunar X PRIZE. So this is a unique opportunity that myself as a student could not let pass. And the same with those that are here today and those at Penn State.
And I know you have a great 3D model of your lander. Can you tell us a little bit about your launch plans and your plans for when you get to the moon?
Yes, I can definitely elaborate on that. So let me explain a little bit about our launch plans. So we're doing something very similar to what Penn State is doing. We're going to be hitching a ride as a secondary payload on a SpaceX Falcon 9 flight, and it will be integrated into a rack. Our lander mass is about 400 kilograms, and it'll be integrated into this rack, which will be put into a sun-synchronous orbit, and then after that it'll initiate a translunar injection maneuver using its upper stage. Then this translunar injection will provide the necessary impulse to place the payload rack into that cislunar cruise. And as the rack reaches the lunar sphere of influence, the customers pursuing lunar insertions will be jettisoned, or they'll be spit out from that rack. Upon separation, our lander will fly independently, iterating the position attitude updates in the preparation for the lunar orbit insertion. And once that maneuver is done, there will be a lunar parking orbit that the lunar lander will be in, allowing our systems to check for the landing site. And then after that, at the orbit from the lunar parking orbit, followed with power braking motor from the main engine, it will get the lander to be about 2 kilometers above the landing site, and then it'll run a hazard detection avoidance system autonomously, and it'll power itself down and do a soft touchdown, delivering around 35 kilograms of the payload to the lunar surface. Okay, so after explaining how that's getting there, here's a 3D model.
You got to show this off because it's really cool.
This is, yeah.
Thanks, guys. So this is the 3D model. The engine has been severed. Here it is. It's just because this is a 1/20th scale of the lander, and the tanks are supposed to be all black. But what happened was that the 3D printer finished its material, and we had to put a new material, and we ran out of blank plastic. So unfortunately, it's 2 colors. I think it's still kind of cool.
Real problems.
Exactly. So you can see the interior here. Below in the bottom deck, let me take this off because it's sliding off because this is an avionics rack. But I'm just going to try to see if I can close this up a little bit. Inside here at the bottom, there's supposed to be a false floor on top of this where the payloads are going to be placed. These 2 cylindrical shapes here, these are pressure tanks. On the side, these are the tanks that will be holding the fuel with bladders inside of them. So there's going to be feed lines coming from the bottom all the way to the top, and then there's going to be the lines that go directly below here into the main engine to be able to supply that thrust that is needed to perform the maneuvers that I explained. And then other items inside here are wide angle and narrow angle cameras that are going to be facing down while it's in lunar parking orbit. There's also some star trackers that will be pointing upwards, so it'll be flying in this manner, and it'll be capturing the imagery from the surface, and then the star trackers that are on top will be helping the lander determine exactly where it is in space. And then when it's doing the power descent, there's also a laser altimeter at the bottom. Well, you can't really see that, but it's around here. There's a laser altimeter and also 2 other cameras facing down, so it can perform its hazard detection and avoidance system. And then on the very top is the avionics suite, which includes a flight computer, the batteries, there's 3 IMUs, and then there's a communications boxes. And these are all commercial off-shelf components that are built and flight proven from industry. And covering.
What's your final weight? What's your final weight?
400 kilograms. Oh, the final after touchdown?
No. Earlier I think you said 400 grams, and I was thinking you're 3D printing.
No.
So that's why I wanted you to say it again.
Yeah, 400 kilograms total.
Yes.
Well, yes, for the lander. And then at the very top, there's some patch antennas that'll be placed. I'm not sure. I don't think you can see that very well since it's all the same color. But there's a series of patch antennas that will be used to transmit the data, and this entire surface thereafter is completely covered in solar cells. So we tried to simplify it as much as possible without a lot of moving parts. The only thing that will be really moving from the lander are the doors that will be going on these 2 locations so that payloads can exit from the front and the back of the lander. And that's the only thing that was missing from this model.
That's pretty awesome. Now, for those of you out in our viewing audience, I'd like to remind you that we are accepting questions through the Q&A app. No matter where you're watching this, you should have a YouTube video playing that has some sort of a button either on it or near it, depending on the screen, that will allow you to start typing in questions. We already have one that's come in from Nancy Graziano, who writes, what inspired you to pursue the Google Lunar X Prize? Would you jump at the opportunity to follow up with a manned mission to the moon? Let's go back to you, Alwyn. be one of the people building this as an aeronautical engineer. So what got you into this, and how do you feel about getting humans on the surface of the moon?
Okay, well, my story of how I got interested in this kind of stuff is, it's kind of dumb. When I was, I believe, 5 years old, I was talking to my brother one time, and he told me about this star called Betelgeuse that was red. And he said it was so cold that you could live on there. Like, if people got over there, they could live on that sun. And that was the most amazing thing to me at that time. So I went to sleep that night, and I was like, honestly, going to space would be the most amazing thing. And I couldn't really imagine a way to do that. So that was kind of, in hindsight, living on the sun is kind of irrational, but at that time that was amazing to me. But that just kind of sparked something in me that I was really interested in space. So I got really interested in astrophysics was a big thing. I read a lot of books in my spare time, books by Michio Kaku, Brian Greene, so other kinds of physics, Neil deGrasse Tyson. I got really interested in those books, but I like the idea of engineering. I like being able to build stuff. So I was like, what is the combination of space and building stuff? And I was like, aerospace engineering. That's how I got interested in that. And then when I was thinking about things I wanted to do, rocket propulsion seemed to be one of the biggest hurdles that we need to overcome to be able to have interstellar travel. So that's the coolest thing in the world to me as well. So that's how I got interested in aerospace engineering. Then when I decided to go to colleges, I actually didn't really know that Penn State was involved in the Google Lunar X PRIZE. I kind of just got lucky. So I came to Penn State during my freshman year in my freshman orientation class. My professor was actually affiliated with the team, and he told me about it. I was like, I absolutely have to join. I knew very little about engineering except for my freshman courses, but I knew I was willing to learn. I read textbooks in my spare time all the time, went out of the way to learn different things. I joined the propulsion subsystem where a grad student helped me out a lot. I'm currently a rising senior in undergraduate, so the grad student helped me out a lot. After being on the team for a little bit less than a year, he saw I had a lot of will to teach myself things, ability to pick up things, and then I got to where I am right now after that. So I've been on the team for a little bit over 2 years, and that's kind of my whole story of how I got involved in GLXP and the Lunar Line.
So we have a great question coming in from Matthew Jones. He's asking, how can we as interested parties support your cause? It's not like you have, you aren't a major corporation that's planning to make money off of these ventures. This is your passion. How can people help make your passion become reality?
Well, this is an awesome question. Yeah, I'll take this one. So right now we are doing a crowdfunding campaign on RocketHub.com. So you can go to RocketHub.com/LunarLionPSU, and you can donate to our team. So what you can do is basically like it's a Kickstarter campaign. So obviously, as I mentioned before, we can't just say like, hey, give me some money, government, because a stipulation of the Google Lunar X Prize is that you can have fewer than 10% government funding. So that other 90% has to come from private donations, private funding, whether you're a company or an organization that can physically fund it yourself, or an organization like Penn State that has to pull its resources from all angles. So having 600,000 alumni at Penn State really, really, really helps, and these guys have gotten on board 100%. So they've been throwing money at us left and right, and but it's not enough. It's not. These are expensive missions, and these guys really have been helping. But we could use your help too at RocketHub.com/LunarLionPSU.
And this Hangout could use your help in getting these words out. Forward the link to the YouTube that you're all watching and get people engaged so that they can see the passion that these students have. And the road they're on isn't an easy one. When you're 19, 20, when you're not old enough to go buy your celebratory champagne for yourself, people don't tend to believe you when you say that you're a rocket scientist. What are some of the, Ruben, what as you've worked to get your program going in Florida, what are some of the weirdest moments that you've had in trying to convince people that you have a realistic plan to get back to space?
Okay. So that's a very good question, and it's quite interesting how that's evolved since the inception of our team. since we were students, we didn't really have much credibility. So in order to gain that credibility, it takes a lot of time, okay? And you have to have people that are supporting you. So one of the first meetings that we had with the dean of the university and other organizations, presidents and CEOs, and we approached them, they pretty much they said, well, this is impossible, this is not going to happen, you can't do it.
We get that all the time.
Yeah, exactly. So you clearly understand where I'm coming with that, and what does that do to me and to the others of the team? What it does is that it just motivates me more to prove them wrong. That's okay. So they can continue doing that, and then we can continue pushing forward. So it's not a problem. And then as time went by, research is going on. We figure out how to solve minor problems, subsystems that need to be developed, and after a few years, we were able to get a contract with NASA called the Innovative Lunar Demonstrations Data Contract, where we've been supplying them with some data from our development phases, and the majority of that contract is actually going to be geared towards the mission itself. Okay, so that was a huge boost for the foundation and for those that were working on it for quite some time. And then the other thing that gave us additional credibility was when we were able to team up with another Google Lunar X PRIZE team. They signed up to fly on our mission, which was Team Angelicum, and they're going to be flying a 1 kilogram version of their rover on our lander. So we'll be going to the moon together, which is very exciting. And the goal is to create synergy around this competition, and it's not everyone's going to arrive to the moon. If everyone could, the teams that are remaining, that would be amazing. If not, at least all the teams that are participating have been able to specialize in one particular area, and there has been occasions where teams are collaborating with each other in order to help each other develop the parts that are missing for their mission. So it is the outcome of it is phenomenal.
And are you hoping that this foundation that you have started will someday also be able to be part of future manned exploration, to go back to Nancy Graziano's question?
Yes. So the technologies being used to land on the moon from this platform can be utilized for manned exploration. Actually, one of the parts, or one of the contract line item numbers, what they're called as part of the Innovative Lunar Demonstrations Data Contract, is to demonstrate if we can perform a trajectory that could support a manned flight to touch down safely on the lunar surface. So that is something that we intend to pursue. Hopefully the others that have that contract as well, Moon Express and Astrobotic, are intending to do the same. Because it would be to the benefit of everyone that wants to go back to the moon at a later date, that are not necessarily participating in the Google Lunar X PRIZE. So this is the technologies being developed right now for this will be key for future missions.
And do you have pathways that people who are interested in helping you today can work on doing that, as Matthew asked? Do you have your own way for people to donate, to support your team, to otherwise build your success?
Yes. So the Earthrise Space Foundation is a 501c3 nonprofit. You can go to guidestar.org and look us up. You can type in Earthrise Space, and you can see clearly all the projects that we're doing. And it's pretty much black and white. All the information is there, so you can see what the foundation has been up to, what the revenue is, et cetera, and donating via that avenue will help us not particularly mainly not for the mission, but to be able to provide students hands-on experience, because that's the main goal as part of the foundation. We want to be able to engage more students, even if we don't end up flying to the moon, or if we do. Either way, we win, because we want these students to be able to be ready for the future, and putting them together with engineers and other industry partners. That way they can gain the experience that they need. And a perfect example is that we've engaged over 75 students here, and as soon as they've either graduated, we've either hired them directly or they've got a job immediately out in industry. And I hope the same is happening at Penn State, because that's a huge, I mean, if I were an executive or any other company looking at somebody's resume and the student says, I was building this component for a lunar lander, what, that's incredible. And they've learned from that. It's hands-on. It's great.
And this also builds on not everyone in the other degrees that Liam brought up often get professional experience, and here you are working essentially just like a NASA public information officer, helping to get the message out. What's it like for you, who isn't a science major, to say, hey, I'm part of returning to the moon? How do people react, and how are you seeing your colleagues who aren't science majors moving on or staying with the project past graduation?
Well, that's one of the best parts too. Like Ruben said, we do have contracts after graduation. Like they are headhunted basically, and they're hired right on the spot. So companies like Ball Aerospace, we have a couple of students at Ball Aerospace right now because of their involvement with Lunar Lion. But on the non-aerospace side of things, I'm an information sciences and technology student right now. I'm actually double major in IST and French. So you'd say, like, what the heck are you doing on the Lunar Lion team? Like, this is crazy. So what I do on the team is my title is digital media coordinator. So I run the website. I make sure that all of the social media marketing gets done correctly and effectively. And the same happens for the marketing students, the business students. To be able to say that we fund, like, we garnered $100,000+ worth of funds in a month, and to say that you as a student ran a campaign, a marketing campaign, like as a marketing student, one of our marketing students, Marissa Miller, helped run a marketing campaign that garnered over $100,000 in funds in a month. Like, that's nuts to say that you did that before you graduated. Like, before you're out of undergrad, you're doing this. And not to mention putting something on the moon.
It's really amazing what all of you are accomplishing. And I'd like to read a comment that we got from the audience before asking you for some closing remarks. Ruben, just to give you a heads up, I'll be turning to you first. So the comment we have is, engaging today's students gives hope that we will someday have a true spacefaring society. What do you want people to walk away with as they look at all the things that you are accomplishing so young? If they only remember one thing tonight, what do you want them to remember, Ruben?
I want them to remember that people need to pursue what they're passionate about, what their dreams are. Don't let anything get in your way. The more people say no, the more you should the harder you should push. It doesn't matter. Okay, it's because it's what you can accomplish. You're venturing into something that hasn't been done before. Well, in our case, it's been done before in the Apollo era, but privately, once again, with the technology that is available now, it's extremely valuable. You're really you're venturing. You're going into the unknown, discovering new ways to do it with what we have available now. And it's incredible what you can do today versus what was able to happen and be accomplished in the past.
That's excellent. And can you tell our audience how old you were when you started working towards the Google Lunar X Prize?
Boy, 20? I was 20.
That's, as I said, not old enough to buy the celebratory champagne.
Exactly.
Alwyn, what do you want people to walk away with?
All right. I think the biggest thing is that if you really do want to do something, if there's something you're really passionate about, similar to what he said, you can really achieve it if you just push through for it. It's like when I was younger, I guess in middle school, I wasn't too good at school, and one kid said to me one time, Alwyn, stop trying to be smart. You're never going to be smart. And now I'm over here being one of the engineering leads as an undergraduate student trying to send something to the moon. So like if you really are passionate about something, like I was passionate about working on space missions. Even when most of the people who were leadership on the team were much older than me, I was like, I still want to have that significant part. Even if I'm not one of the leads on the team, I still want to have that significant part. If there's something you're passionate about and you really put all your all of you into it, in no time you're like something's gonna happen, or you're gonna get lucky. Where my definition of luck is opportunity met with preparation. If you just work hard at it, something's gonna happen and it's gonna work out, and that's what you need to do. And in particular with space, we're at a really big point in history in terms of pushing space, human space travel, human space exploration, and just understanding of space with a private industry growing so much, having things like the Google Lunar X PRIZE. If you just push through for it, now is the time to make that happen.
That's really awesome. And how old were you when you started on the Lunar Alliance?
I believe I was 19 years old, and I'm 21 now.
Excellent. And Liam, let's go to you.
Well, if I had to say something that was a takeaway, you guys are all familiar with the Google Lunar X Prize, and it's a $20 million cutthroat competition to get something on the moon. But for these two teams, especially, it's not just about that. It's something more. And at Penn State, as well as what Ruben was saying, we believe that it's about educating the next generation. We, as students, are going to be the people that go even further in space. Those guys that want to get out there and want to learn more. And here we are. I mean, you're going to ask me how old I was when I was interested, when I started on the GLXP, and I was 18, and I'm 19 now. So Alwyn's buying the celebratory champagne, but this is the this is the time to get interested in space, and it's about teaching the next generation and inspiring students here.
This has been an amazingly inspirational hangout, and the group of you are proof positive that youth are capable of anything when they work together, and the world is being taken back from the Apollo generation as the younger generation says, nope, it's our turn to go to the moon.
Alwyn, Ruben, let's do it.
We're going to do it.
I have to thank you all for joining us. We will have another hangout in 2 weeks. And I'd also like to point out that as I was opening the green room for this hangout about 2 hours ago, a gamma ray burst, we think it might have also been an ultraluminous X-ray burst, went off in the Andromeda galaxy. This is the nearest high-energy source, if it was a gamma ray burst, that we know of. So the next 24 hours is potentially very exciting on the astronomical side of exploring our universe. So check out GRB M31 hashtag on Twitter and Google+, and stay tuned to find out more about our next hangout as we post the details. Thank you so much, gentlemen, for joining us, and go to the Google Lunar X Prize website to learn more about all 18 teams. And if you'd like to help map out the moon so that these guys know where it's safe to land and where the science is awesome to explore, go to cosmoquest.org. I'm Dr. Pamela Gay, and this has been the Google Lunar X Prize Team Hangouts. Thank you.
Thank you, Pam.
Thanks.
Bye, guys.
X PRIZE. We're going to do so by purchasing a place on another rocket. We're not going to build the launch vehicle ourselves. So we're going to get onto a rocket. Hopefully there'll be other secondary payloads on there. There will be other secondary payloads. That rocket is going to take us to the moon. One really interesting thing about that is that we're using a payload integrator called Phoenicia, who used to be one of the competitors in the team, but they dropped out of the prize and started a new thing by pretty much being a broker that bridges the gap between the people trying to get a launch vehicle and the launch vehicle itself. So they're helping us get our launch contract. We have it almost signed. We have it almost completed. We're in the process of doing that. So we'll be launching on that vehicle, which I can't announce yet. It will send us into a translunar insertion orbit and set us on a collision course to the moon. And at that point, that's when our own systems will take over. So we're going to be on a collision course to the moon. If we don't do anything, our lander is just going to smash into it and blow up. But that will not happen.
It will not.
Rocket, hopefully. We'll have a solid rocket motor that is attached to the bottom of our spacecraft that slows us down.
Two teams unique is their student engagement. Omega Envoy is a team that grew out of the Earthrise Foundation, a foundation that was formed by Florida students that is dedicated to getting student projects into space. This is the first student team of its kind. The Penn State Lunar Lions team is the only university-based team in the Google Lunar X PRIZE competition. So tonight, we're talking not to a bunch of PhDs, not to a bunch of people that worked on the space shuttle program, but literally the next generation of explorers. And when us professors say it's today's college students that are on their way to the moon, it's these students that are pioneering this trip. So I'm going to start over with Alwyn from the Lunar Lions, Alwyn Paul. He's the vehicle design lead, and ask him to tell us a little bit about what the Lunar Lions are planning.
All right. Well, like she said, my name's Alwyn Paul, and I'm the vehicle design lead. What the Lunar Line team is doing is we're going to complete the Google Lunar X. It brings us to about 2 meters. I forgot how many exactly, but that's image of it. So it brings us to a manageable speed. Then the solid rocket motor, which is the part that you see coming off in step 4, that part will be detached, and then thrusters that we have on the sides of our craft will bring us down to 2 meters per second. Once we get to that velocity, we're going to land on the moon. We have crushable honeycomb pads on the bottom of the craft that will absorb the shock from the initial landing. We'll land, we'll take video, high-definition video, pictures, send some data back, and then one of the other requirements of the prize, other than landing on the moon, is to move 500 meters laterally. To do that, the thing we're going to do is instead of roving, we're actually going to hop to the side. The reason we're doing that is because no matter what, there's pretty much no atmosphere on the moon, so you can't really use a parachute. The only way you could slow your velocity down so that you don't blow up when you hit the moon is to have a propulsion system, so rocket engines. So we're going to use that same system that we used to bring us slowly down to the moon to actually make us hop 500 meters.
Hello and welcome to our 5th Google Lunar X Prize team hangout. This week we will be talking to the Penn State Lunar Lions and the Omega Envoy teams about their pursuit of the Google Lunar X Prize. To win a team, and we don't know which team it's going to be yet, there's so many variables. A team must land safely on the moon, traverse a distance of 500 meters by any means of their choice, and then send high-definition video back to Earth. And what I love about this competition is just how free-form it is. We can have a walking robot boogieing its way across the moon. We can take off, and land somewhere else, or just do the normal rover kind of thing. During the next year, the Google Lunar X Prize Team Hangouts are going to follow not just these 2 teams, but all 18 of the teams that are still in the running and registered in this competition as they work their way toward launch, landing, roving, flying, whatever they're off to do, and the video that they're sending back. What makes tonight's
and that will be the conclusion of the mission after we send the data back and take another video.
And this is all something that you're working on at Penn State University. Can you tell us a little bit about the composition of your team?
Okay. Liam, you wanted to say some stuff about that?
Yeah, sure. So I started out on this team, and I said, I'm not an aerospace engineer. I'm not even an engineer, but this is some of the coolest stuff I have ever seen. So I want to be a part of it. And they were like, well, what do you bring to the table? I was like, well, I did acting in high school. I really like public speaking. My major is in information sciences and technology. And they were like, well, that's great. Why don't you just hop on board? And here I am talking to people every day. But it's just one of those things where our team composition is very, very diverse. Previously, on previous space missions, you basically said, hey, Papa President, we need like $400 million yesterday. So the thing that's different about these new space initiatives is that we need to not